All right, looking for relative extrema given the f prime equation. So our critical numbers are going to be at 2, 3, and 4. Let's plug in 0. If x is 0, this is negative. This one is going to be positive no matter what, so we can kind of ignore it. That wouldn't be negative. Negative times negative is positive. We know 2, it's going to flip signs across 2. Across 3, this is squared, so it's not going to flip signs here. So it'll still be negative. And across 4, that is an odd power, so it will flip signs. This is positive to negative, so that is a maximum. Negative to positive, this is a minimum. 3 isn't anything. So the only one that was true was 1. Here we want to know where f is increasing, so first start by finding f prime, which is 300 minus 3x squared, set that equal to 0. So I'm going to pull a negative 3 out. And that's going to leave me with positive x squared minus 100. That's x minus 10, x plus 10. And now we make 10 and negative 10. Plug in 0 to our f prime, and our derivative would be positive. So then that means that is increasing from negative 10 to 10, b. Relative maximum, positive to negative, so that's at x equals 10. Minimum from negative to positive, that's at x equals negative 10. Puddle of water is increasing in the rain if the area of the puddle is increasing at a rate of 3. So this is dA dt is 3. When the radius is 2, how fast is the circumference changing? So dc dt. So we need to know our area of a circle is pi r squared, and the circumference of a circle is 2 pi r. dA dt, when we take derivative with respect to time, that would be 2 pi r dr dt. We know dA dt is 3, 2 pi radius is 2 dr dt. So this is just 4 pi, divide over, 3 over 4 pi is r dr dt. And then now we're ready to find dc dt. So we take the derivative, this is going to be 2 pi dr dt. 2 pi, dr dt we just said was 3 over 4 pi. The pi's cancel, 2 over 4 becomes over 2, so this is just 3 halves. Here we want to find where if it's continuous or differentiable. Continuous we'll just plug in, so 3 squared when we come from the left is 9. 6 times 3 minus 9 is 18 minus 9, which is also 9, so this is continuous, right? We can cross off these ones. Now we need to take the derivative for differentiable. This is 2x, this is 6, so 2 times 3 is 6, which is equal to 6, so it is also differentiable. First we want to find dy dx in order to find the second derivative. So we've got 2y dy dx plus dy dx equals 1. So then dy dx is 1 over 2y plus 1. Now when we take the second derivative, you actually don't need to do a quotient rule because I don't have variables on top and bottom, I just have on bottom. So let's just rewrite this as 2y plus 1 to the negative 1. So when I take the second derivative, this is going to be, pull the negative 1 down, 2y plus 1, adds to the negative 2 power, so I subtract 1, multiplied by derivative the inside, which would be 2 dy dx. So I'm going to rewrite this as negative 2 dy dx over 2y plus 1 squared. And then I just want it at a point, so I'm going to plug in y is 1, so that would be 2 times 1, plus 1 is 3 squared, so this is over 9, negative 2. Now dy dx is this right here, so let's just plug in, this is 1 over, when y is 1, 1 over 3, like this. So I've got negative 2 times 1/3 over 9, so that's negative 2 over 3 times 9 is 27 on the bottom, so that's A. Here we've got tangent in terms of u in terms of v in terms of x. So if we want dy dx, we need to get y in terms of the x. So I'm going to plug this in for the v's. So u is natural log minus 1 over natural log, and I can plug that in for u. So then y is tangent of natural log x minus natural log x. And now I'm ready to take the derivative because now I have y in terms of x. So dy dx would be secant squared of natural log x minus 1 over natural log x times derivative inside. Derivative of natural log is 1 over x. Now I'm taking derivative and do this off to the side of natural log 1 over natural log, negative 1 over natural log, which is natural log to the negative 1. So when I take the derivative of this, that multiplies, it becomes positive natural log to the negative 2 power times derivative of natural log of the inside, 1 over x. So this is plus 1 over natural log of x squared, 1 over x. Right, and now we're plugging in when x is e, so natural log of e is just 1 to saying e to what power gives me e to the first power, so this is secant squared of 1 minus 1 over 1 times 1 over e plus this just becomes 1 over e. That's secant squared of 0. Secant is 1 over cosine. Cosine of 0 is 1, so this goes away. And we've got 1 over e plus 1 over e, which is just 2 over e, d. Conical cup is 4 centimeters across and 6 centimeters deep. Water leaks out at a rate of 2 cubic centimeters per second. How fast is the water level dropping when the height is 3? So when the height is 3, we want to know how fast the height is dropping, dh dt. And we know that it's filled up at a volume changing by a rate of 2. So dv dt. We have the volume in terms of R and H. I really just want it in terms of H. So if we draw a quick picture of a cone, if this is 4 centimeters across, that means my radius is 2, and it's 6 centimeters tall. This is 2. Now, we can just make a general ratio, right? Your radius over your height is going to be 2 over 6. So then if we say, okay, well, R is just 1/3 H, right? I'm just rearranging this for R. We can replace R in our equation. So now our volume is 1/3 pi. R we just said was 1/3 1/3 H squared times H. Not taking the derivative yet, right? All I'm doing is finding V in terms of H so that I don't have R in my equation because I don't really know anything about R. This is 1/9 H squared. 1/9 times 1/3 is 1/27 pi. H squared times H would just be H cubed. And now that I have the volume just in terms of the height, now I can take derivative. dv dt is 3. That would become 1/9 pi H squared dh dt. dv dt is 2. 1/9 pi H is 3. dh dt. This cancels out, 1/9 and 9, divide 2 by pi to get dh dt. Alright, position, so first let's find velocity, that's going to be 3t squared minus 18t plus 24. I want to know where the velocity is 0, where it's at rest, so t squared minus 8. So it's at rest at t equals 2 and t equals 4. T equals 1, what's happening? So let's find the velocity at 1. 1 would be 3 minus 18 plus, 15. That's positive. Either way, it's positive. Find acceleration in terms of t first. So acceleration is going to be 6t minus 18. So a of 1 is going to be negative. So that means that it's slowing down because a and b are opposite signs. Here we need to justify all of our answers. We have a graph of f prime, the derivative. I want to know where f is increasing. So I'm going to go ahead and write because f prime is positive. Or you can say f prime greater than 0. Because I know that where f is increasing, f prime is positive. So the only section where the graph of f prime is positive is -3 to -2. Concave up, so we know that concave up means f double prime is positive, but I don't have a graph of f double prime, I have a graph of f prime, so ignore that reasoning. Let's think about what f prime is doing. Concave up means f prime must be increasing, so it is only increasing from 0 to 2, because f prime is increasing. Now we're looking at points of inflection. So points of inflection is when f prime changes the decreasing, increasing, or flipped. So that's changing here, and it's also changing here. So at x equals 0, because f prime changes from decreasing to increasing. And also x equals 2, because f prime changes from increasing to decreasing. So make sure you match this description to the point, right? Don't say x equals 0 and x equals 2 because it changes from increasing to decreasing or decreasing to increasing. Match each one. And equation for the tangent line at this point. So y minus 3 equals the slope x minus 0. So I can just say x. And now I need to know what the slope is. Well, the slope is just going to be f prime of 0. Go to 0, f prime, right? We have a graph of f prime is negative 2. So y minus 3 equals negative 2x. Make sure you look at the whiteboard practice that I uploaded